Hi, I am Revati, Assistant Professor, Department of EEE, SNS College of Technology. In this lecture series video of Fundamentals of Electrical and Electronics Engineering, today's topic is about bipolar junction transistor. So, talking about bipolar junction transistor, we already know about the PN junction diode. What is forward bias and reverse biasing condition? Can a diode conduct in reverse direction? Why do we require voltage regulator? So, coming to the point, a diode is a unidirectional, unijunction, two layer, two terminal bipolar device. So it is used in a n number of varieties of applications like LED, bulb, etc. So PN junction is a two types of junction. There is a layer called P-type layer and N-type layer, whereas P-type layer is completely filled with holes, majority holes, and the minority holes is electrons. Where in N layer, majority carrier is electrons and minority carrier is holes. So diode conducts only in forward bias condition. Wherever the knee voltage achieved, the diode start conducts in forward bias condition. Whereas in reverse bias condition, the terminals are changed across the diode and the supply starts to conduct, a leakage current is formed and then a sudden breakdown occurs, that is known as avalanche breakdown or breakdown region. So this is known as PN junction diode. So it is operates only in forward bias, whereas in reverse bias condition it does not conduct any current in the devices and the device will easily breaks. So that we cannot use the diode in a reverse direction. So talking about PN junction, there is an semiconductor layer, silicon and germanium, where intrinsic and extrinsic semiconductors act, whereas intrinsic semiconductor is a purest form of semiconductor, whereas extrinsic semiconductor is a impurities added in the purest form of semiconductors. So what is BJT is it is advanced version of diode, which is a transistor. So after the invention of transistor, only the electronics get blooms. So the electronics technology is increased by the invention of a transistor. So transistor mainly act as a switching device, whereas it is for classified into many types: MOSFET, FET, field effect transistor, metal oxide semiconductor field effect transistor, junction field effect transistor. So whereas BJT is a bipolar junction transistor. So as like diode, it is also a three layer, three terminal, unidirectional bipolar transistor. It consists of two junctions. So three layers are NPN transistor or PNP transistor. So one type of layer is sandwiched between the other type of layer. Whereas in NPN transistor, N act as a two-side layer and the middle layer is P type. Whereas in PNP transistor, N act as a middle layer and P act as a layer. So N act as a middle layer. So three terminals are base, collector and emitter. Whereas emitter act as a emitting the charges and the collector collects the charges. Whereas base act as a path between these emitter and collector. So, bipolar junction transistor consists of two N-type and one P-type and two P-type and one N-type layer, NPN and PNP transistor. So, whereas in emitter, the current flows is known as emitter current and the collector current, base current. Whereas in collector NPN transistor, the arrow marks denotes in the inward direction, whereas in N-type transistor, that is in an outward direction. So emitter is highly doped material where it is able to push the charges to the collector part, whereas collector is a lightly doped material, it collects the charges. So base cannot act as a doped layer because it acts only as a path between emitter and collector. So the space of NPN transistor is N is a medium space and base is a smallest space and collector is the highest spacing in a layer. So this is middle section, it's thin than the other two junctions. So transistor have three section of doping: emitter, collector and base. We all know that. So emitter is a forward biased where to base, so it can supply carrier. NPN transistor emits supply holes to its junction. So whereas in collector, the other side that collects carrier is called collector. The middle section which forms two p-n junction between emitter and collector is known as base. So base is much thinner than other region. Emitter is highly doped, base is lightly doped, and collector is mediumly doped layer. So the junction between the emitter base junction, the junction between collector base is known as collector diode, whereas it acts as a resistance of collector in a high, which is in reverse bias direction. Emitter diode is very low, which is in a forward biasing condition. So this is the flow of charges, whereas two n-type and one p-type layer is discussed in the circuit diagram, where it is emitter base junction causes the diode to be forward towards the base. So the working is a recombination of electron constitute a small base current, where electrons crosses base constitution collector current. So when electrons flows towards a p-type base, they then they try to recombine with holes. As base is lightly doped, only few electrons recombines with holes within the base. So the forward bias is applied to the emitter base junction and reverse bias is applied to the collector base junction. So these recombination holes constitute as an lightly doped, only few holes recombines with electrons within the base. So common base, common emitter, common collector are the three ways of transistors. So these are all the construction of an BJT. So the input characteristic is shown below across the emitter current to the voltage of common collector base and emitter base. So the output characteristics is drawn across the collector current and emitter current. So the input characteristics of VE is equal to 0, where VCE is less than 0 volt. So the current amplification factor in common emitter connection, input current is base current and output current is an emitter current. So these are all the things which we have discussed in the BJT. Thank you.